What specific problem does the Hybrid Multimodal Memory module aim to solve in the context of long-horizon tasks for agents like Optimus-1?
The Hybrid Multimodal Memory module aims to address two specific problems in the context of long-horizon tasks for agents like Optimus-1: insufficient exploration of structured knowledge and lack of multimodal experience. Existing agents struggle to efficiently represent and learn structured knowledge, which is crucial for understanding open-world rules and object relationships, leading to their inability to perform complex tasks. Additionally, these agents typically rely on unimodal information, preventing them from leveraging the rich multimodal experiences that humans use to derive strategies from historical data. The hybrid multimodal memory, composed of the hierarchical directed knowledge graph (HDKG) and the abstracted multimodal experience pool (AMEP), provides a structured representation of knowledge and incorporates both successful and failed experiences, thereby enhancing the agent's ability to adapt and plan effectively in complex environments. This innovative approach significantly improves the agent's performance on long-horizon tasks by enabling it to reflect on past experiences and refine its actions accordingly.
Can you break down the workings of the proposed hybrid multimodal memory and its components, HDKG and AMEP, step by step?
The proposed hybrid multimodal memory, HM, consists of two main components: the hierarchical directed knowledge graph HDKG and the abstracted multimodal experience pool AMEP. First, HDKG transforms structured knowledge into a directed graph, where nodes represent objects and directed edges indicate relationships, allowing the agent to retrieve necessary knowledge for task execution without parameter updates. This structured representation enhances the agent's ability to plan long-horizon tasks by providing a clear understanding of the relationships between various game elements, such as crafting requirements in Minecraft. Second, AMEP dynamically summarizes and stores multimodal information, including environmental data, agent states and task plans, during the agent's execution process. It filters visual information from video streams and aligns it with textual sub-goals using a pre-trained model, ensuring that both successful and failed experiences are stored for future reference. This dual consideration of outcomes enriches the agent's learning process, enabling it to reflect on past actions and refine its strategies effectively. Together, these components allow the agent to leverage structured knowledge and historical experiences, significantly improving its performance in complex, long-horizon tasks.
Could you provide a simple example detailing how the knowledge-guided planner utilizes the hierarchical directed knowledge graph, HDKG, during task execution?
The knowledge-guided planner in Optimus-1 utilizes the hierarchical directed knowledge graph, HDKG, to enhance task execution by retrieving structured knowledge about object relationships and crafting requirements. For instance, when tasked with crafting a diamond sword, the planner accesses HDKG to identify that it requires 2 diamonds and 1 wooden stick, which are represented as nodes in the graph. The directed edges in HDKG illustrate the crafting relationships, allowing the planner to efficiently decompose the task into executable sub-goals, such as first mining for diamonds and then crafting the sword. This structured approach enables the agent to generate a comprehensive plan in one step, rather than iteratively refining it, thus improving the efficiency of task execution. By leveraging HDKG, the knowledge-guided planner ensures that the agent has the necessary world knowledge to complete complex tasks effectively.
What empirical evidence did you provide to demonstrate the effectiveness of Optimus-1 compared to existing agents, and what metrics were used to evaluate its performance?
To demonstrate the effectiveness of Optimus-1 compared to existing agents, we conducted extensive experiments using a benchmark of 67 long-horizon tasks in Minecraft, evaluating its performance against various agents, including GPT-3, 5 GPT-4v, DEPS, and Jarvis-1. The empirical evidence showed that Optimus-1 achieved a near 100% success rate on the wood group and exhibited significant improvements of 29. 28% and 40% over Jarvis-1 in the Diamond and Redstone groups respectively. Additionally, Optimus-1's performance was closer to human levels, with an average improvement of 37% across all task groups compared to baseline agents. The evaluation metrics included success rate, average steps, and average time taken to complete tasks, ensuring a comprehensive assessment of its capabilities. These results highlight the substantial advancements made by Optimus-1 in executing long-horizon tasks effectively and efficiently.
Discuss the significance of incorporating failure cases into the Abstracted Multimodal Experience Pool, AMEP. How does this contribute to the overall functionality of the Optimus-1 agent?
Incorporating failure cases into the Abstracted Multimodal Experience Pool, AMEP, is significant as it enhances the learning process of the Optimus-1 agent by providing a comprehensive reference for both successful and unsuccessful task executions. This approach allows the agent to reflect on its actions during the experience-driven reflector phase, categorizing outcomes as complete, continue, or replan. By analyzing failure cases, Optimus-1 can identify errors and adjust its planning accordingly, which is crucial for improving its performance on long-horizon tasks. The inclusion of failure cases not only enriches the agent's historical experience, but also fosters a more robust learning mechanism, enabling it to adapt and refine its strategies in complex environments. Overall, this innovative method significantly boosts the agent's success rate and efficiency in task completion, demonstrating the effectiveness of the hybrid multimodal memory framework.
What potential limitations or challenges can arise from using the proposed method, particularly concerning the scalability and complexity of the hybrid multimodal memory module?
The proposed hybrid multimodal memory module, while innovative, may face potential limitations regarding scalability and complexity. As the module integrates both the hierarchical directed knowledge graph, HDKG, and the abstracted multimodal experience pool, AMEP, the complexity of managing and updating these components could increase significantly with the addition of more tasks and experiences. The HDKG's reliance on a directed graph structure for knowledge representation may lead to challenges in efficiently storing and retrieving knowledge as the graph expands, potentially resulting in slower performance. Additionally, the AMEP's need to summarize and store multimodal information from various task executions could become cumbersome, especially if the volume of data grows, complicating the retrieval process. Lastly, the method's effectiveness in incorporating both successful and failed cases into learning may require sophisticated algorithms to ensure that the agent can effectively discern and utilize this information without overwhelming its memory capacity.